Yes, welcome to another geometry lesson on Monday evenings. Today we'll be solving some questions on Euclidean geometry to do revision for your test as well next week, Monday. So let's start with the first question. In the diagram, triangle ACD is drawn with points A and D on the circumference of a circle. CD cuts the circle at B. P is a point on AD with CP, the bisector of ACD. So as soon as you read these, just indicate these on the diagram so that you can forget later on that if you indicate on the diagram that you'll see. If CP is bisector of ACD, that means this angle also will be 25. So that C1 will be equal to 25 too. CP cuts chord AB at T and AT is equal to AP. That's indicated on the diagram. ATP is 65. That's also on the diagram. PCD is 25. Determine the size of each of the following angles. For these questions where it says 2 marks, it is just like see and answer question. You'll just see the answer and then provide your reasons. So in the first one, P2 is, as you can see, base angle of this isosceles triangle. Therefore, it's going to be equal to 65. The reasoning for this one would be angles opposite equal sides. So after you got P is 65, you can write it down here. Next one is D. So you can see that D is subtended by this arc here. But since there is no other angle subtended by same arc at the center or the circumference, we won't be able to use theorems. Then we can use our properties of triangle. You can see that this 25 is interior angle, D is interior angle, and P2 is exterior angle. So 65 is equal to 25 plus D. Reason is exterior angle of triangle. Therefore, D will be equal to 40. Okay, so we got 40 here. And then A1 is here. A1, again, I can't use any theorem for this A1 because AC is not tangent, it's not given. I can use cyclic quadrilateral or angle at center. Again, you can see that 65 here is exterior angle, A1 and 25 are interior angles, opposite interior angles. Therefore, we can say same thing for A1 as well. So 8.1.3 A1 plus 25 will be equal to 65. Reason is exterior angle of triangle. And then if you simplify this equation, A1 will be equal to 40. Is CA a tangent to the circle ABD? Motivate your answer. For CA to be tangent to the circle, remember what we learned about tangents, that we had 3 theorems about tangents. One is this. Angle between tangent and radius is always 90. Or angle between tangent and chord is equal to the angle subtended by same chord. Or we have these 2 tangents from same exterior point. Obviously, it is not number 1, not number 3. We'll use number 2 here. For CA to be tangent, we need to be able to find 2 angles that are equal to each other. One must be between tangent and chord. Other one is subtended by same chord. Let me change my color and show you here. If CA is tangent to the circle ABD, so if you draw a circle around ABD, right, let's say this is our circle around ABD. So this is our line. That's our chord. So the angle between chord and line is what? 40, which is proved in the previous question. The angle subtended by same chord is also 40. Therefore, your answer going to be for 8.2. Yes, it is a tangent. Why? Because A1 is equal to D. Reason is converse, right? Converse 10 chord theorem. Because of this converse 10 chord theorem, CA will be a tangent. This question could have been also like prove that CA is a tangent. Then you just say, in that case, you just say A1 is equal to D. Therefore, CA is a tangent, and reason would be converse tan-chord theorem. Okay. Any questions? So it's a nice question for you to practice. Good evening, everyone. Good evening. Thank you. Right, let's have a look at another question. Question number 9. In the diagram, O is the center of the circle, and BO and OD are drawn. Chords CB and DE are produced to meet in A. Chords BE and CD are drawn. BCD is X. Give the reason for each of the statements in the table. Complete the table provided in the answer book by writing down the reason for each statement. So if I check here, C is given, and statement is E1 is equal to X. Why is this? If you check D, C, B, and E are all on the circumference, that makes B, C, D, E a cyclic quadrilateral. Therefore, reason for this one would be exterior angle of cyclic quadrilateral. O1 is equal to X, 2X, sorry. So if you check C, it is subtended by arc BD. O1 is also subtended by same arc. Therefore, the reason for this would be angle at center is equal to 2 times angle at circumference. Okay. Next question is, if it is given that BE is parallel to CD, so BE is here, parallel to CD, prove that AC is equal to AD. So if two sides in a triangle are equal, like if this side is equal to this, then their angles will be equal as well, right? So it's a two-way theorem. Like if sides are equal, then angles would be equal to. If angles are equal, then sides would be equal to. So when we try to prove that two sides are equal, we look for two angles that are equal to each other. If you try to prove that two angles are equal, then you need to look for two sides equal. So if you want to show that AC is equal to AD, okay, AD is here, AC is here. So that means C must be equal to this angle here, D1 plus D2, right? So why do you think that they gave us these parallel lines here? In order to solve the following question. So as a result of these two lines are being parallel, we can conclude that, like 9.2.1, we can conclude that CDA, right, is equal to X. Why? Because of corresponding angles as EB parallel to CD. Okay. If this is X, then that's going to be X as well. Now you can see that ADC is equal to angle C, both equal to X. Therefore, AC is equal to AD. Reason is sides opposite equal angles. 9.2.2 ABOD is a cyclic quadrilateral. Again, in order to prove that a quadrilateral is cyclic quadrilateral, again, we have three ways of doing this. Number one, in any quadrilateral, if you find two angles are supplementary, like these two angles are 180, x plus y is equal to 180. Or in any quadrilateral, if you show that one exterior angle is equal to opposite interior angle, or in any quadrilateral, if you have diagonals, and in these diagonals, if you just can find these two angles are equal to each other, like same segment, angles in same segment. If you find a line subtends two equal angles, then you prove that it's a cyclic quadrilateral. So clearly, number 3 is not the option here because I don't have diagonals in AB OD. Okay, because I'm looking for ABOD. So ABOD is basically this one here, AB O D. This is the case. So one angle is already given as 2x from the previous question. So as a result of parallel lines, I can prove that this is 9.2.2. I can show that B3 is equal to x, okay, which is this angle here, equal to xy, as a result of corresponding angles. YBE parallel to CD. So this angle is equal to x. E1 is also x. Then angle A will have to be 90 minus, no, 180 minus 2x. 180 minus 2x, y, sum of angles of triangle. Because in triangle ABE, if you add all these three angles, that must add up to 180. So 180 minus 2x will be A. Opposite of A is O1. So you can see that. Can you see that O1 plus A is equal to 2x plus 180 minus 2x. That's equal to 180. Therefore, ABOD is a cyclic quadrilateral. Cyclic quadrilateral. Reason is converse opposite angles of cyclic quadrilateral. Okay, we use number 1 here. We found two angles whose sum is 180, A and O1. Okay. Yes, question 10.1. Complete the following statement of the theorem in the answer book. As you can see, you get a question like this as well, like completing the sentences or completing the statements of the theorem. Therefore, you need to learn all the theorems on page number 5. If a line divides the two sides of a triangle in the same proportion, like look at this, EF, for example. If EF is dividing two sides proportionally, then it is parallel to the third side. Okay, remember proportional theorem. Proportional theorem, if this line is parallel to third side, then sides will be divided proportionally. The converse of this theorem was if it is divided like both sides proportion, like if this is 1, that is 2, if this is k, that is 2k, 1 to 2, k to 2k, then line has to be parallel to third side. Okay. Then 10.2, in the diagram, ABC is a triangle with F on AB and E on AC. BC is parallel to FE. D is on AF such that AD or AF. So if AD is here 3x, then AF would be 5x. So that would leave us with DF as being 2x. Okay, this is how you use the given ratios. AE is given as 12, then EC is 8. Prove that DE is parallel to FC. So for these two lines to be parallel to each other, we need to find two sides are divided proportionally. If you check AD and DF, what is the ratio of AD and DF? According to those x values, 3x or 2x, which is equal to 3 or 2. If I check AE or EC, that is 12 over 8. So if you simplify that, 12 divided by 4 is 3, 8 divided by 4 is 2. Therefore, as you can see, AD or DF is equal to AE or EC. Therefore, DE is parallel to FC. Reason is converse prop theorem. Okay. This is how you use proportional theorem or converse proportional theorem to prove that DE is parallel to FC. We just proved that now these two parallel to each other. If AB is 14, then calculate the length of BF. So again, let me change my color here so that you can pick up. Now look at this. Since this line here is parallel to BC, right? As a result of this parallel line, these two sides will be divided proportionally, like BF or FA will be equal to C or EA. Remember that you can write other versions as well. Like one version would be BF over BA is equal to CE or CA. Okay. As a result of these parallel lines, 10.2.2, I can write down the ratio as BF or BA is equal to CE or CA. Okay, reason is prop theorem. Why? Because FE is parallel to BC. And then BF is the unknown. That's what we're looking for. Right. I'll keep BF. BA is given as 14. CE is given as what? 8. And CA is 20. 8 plus 12, 20. So if you solve this, again, it's going to be 8 divided by 4 is 2. 20 divided by 4 is 5. That's going to be 28 or 5. Okay, if you cross multiply. Or you can say 8 times 14 over 20, and then if you simplify it, you'll get 28 over 5. Yes, next question is the proof question here. We did this in class many times. This is proof of 10 chord theorem. Answer is on page 5 on circle geometry booklet. Or let me just quickly answer for you here. So you need to remember here the construction part for this. Okay, the construction part for this question would be, let's start with construction. Draw diameter, right? Diameter AOD. So you're gonna draw this diameter AOD and join CD. So let's join CD. So let's call BAP, right? So let's call this one A1, A2, C1, C2. I'm just trying to prove that because BAP is A1, ACB is C1. So I'm just going to prove that A1 is equal to C1. So from the theorem, first theorem, radius perpendicular tangent, we can say that A1 plus A2 is equal to 90. Reason is radius perpendicular tangent. And then C1 plus C2 is equal to 90. Why? Angle in semicircle. Because diameter AOD subtends C1 plus C2. Therefore, A1 plus A2 is equal to C1 plus C2. But C2 plus is equal to A2. Why? Because C2 is subtended by BD and A2 also subtended by same arc. Angles in same segment. Therefore, C1 will be equal to A1. C1 is same as ACB. A1 is same as BAP. Okay. If C1 is equal to C2 is equal to A2, then when you subtract them from each other, you end up with C1 is equal to A1. If A2, like A2 minus C2 is equal to 0, then you have A1 is equal to C1 left. Okay. This is the proof of 10-chord theorem. Yes, we have this last question for this chapter. In the diagram, C is the center of the circle, DAP, and BA is a tangent to the circle at A. CD is produced to meet the tangent to the circle at B. DP and DA are drawn. E is a point on BA such that EC bisects DCA. Again, as soon as you see this here, just translate it on the diagram. EC bisects DCA means if C1 is X, C2 will be X as well. Okay, because of this. Now prove that BAD is similar to BCA. Remember that when we did similarity theorem, we need to find out that three angles are equal to each other. So what is BAD in B? BAD in B is this angle here. And when you check triangle BCE, you'll see that it's exact same angle, which is B. Therefore, we can start with angle B. So you say B is common. As you can see, this question is 7 marks. That means we need to spend some time to get the second angle. B is the easiest one, but we need to show like one more angle. So what is A in BAD? It is BAD, it is A1. What is C in BCA? It is C1. What is D in BAD? It is D1. What is E in BCE? It is E1. So I need to show that A1 is equal to C1 or D1 is equal to E1. Then we prove the question. So let's see now what we have from the questions. So I can see that DC is 10 radius. AC is also radius. So we have isosceles triangle here. Then I have this angle here. BD, ADC, right? ADC is equal to A2 Y angles opposite equal sides. Therefore, 2 times ADC plus 2x must be 180. From this, if you solve for ADC, ADC will be 90 minus x. So if this is 90 minus x, then D1 will be equal to 90 plus x. Y angles on a straight line. Okay. And then what about E1? You can see that now E1 is exterior angle in this triangle here. Look at this triangle. EAC is it's 90 degree because radius perpendicular tangent. E1 will be equal to 90 plus x exterior angle of triangle. After we prove that this is 90 degrees, C2 is x, so x plus 90 will be 90 plus x. We found out this one also was 90 plus x. So we just proved that now D1 is equal to C1, therefore D1 is equal to C1, and A1 will be equal to C1, sorry, D1 is equal to E1, and A1 is equal to C1. Reason is third angle of triangle. Therefore, triangle BAD is similar to triangle BCE. BCE. Reason is angle, angle, angle. Next question, if it is also given that AB is equal to 8. So if this part is 8, AC is 6. AC is 6. calculate the length of BD. So since this angle is 90 here, I can apply Pythagoras theorem for this. So we can say 11.2.2a. We can apply Pythagoras theorem. BC square is equal to 6 square plus 8 square because of Pythagoras theorem. From this, BC is equal to 10. If BC is 10, AC was radius, then DC also going to be 6. Then BD will be equal to 4. Then BD will be equal to 10 minus 6, which is equal to 4. Okay. 10 minus radius, which is 6, will give us BD. Length of BE, let's do it here. Length of BE, since this is not part of right angle triangle, we cannot use Pythagoras theorem here. We have similarity, proven similarity in the previous question. We can use the ratios from similar triangle. Look at these similar triangles here. We can write down the ratios from these. AB or, I can write down the similar ratios. AB or BC is equal to BD or BE. Okay, similar triangles. So what is AB given as? It's given as 8. What is BC? 10. What is BD? 4. What is BE? Unknown. Okay, from this 8 BE is equal to 40, then BE is equal to 5. If BE is given as 5, then this side has to be 3. And next question, the size of X. Since X is an angle in this right angle triangle here, we can apply sine cos 10 ratios. Look at this triangle. In this triangle, one angle is 90, 3 is opposite, 6 is adjacent. So you can say 10x is equal to 3 over 6. So if you apply shift 10, 3 over 6, x will be 26,57. Or you could have used bigger triangle, like in triangle ABC, you can use sine 2x is equal to 8 over 10. Okay, and then you can say shift sine 8 over 10. That will give you the angle, and then if you divide it by 2, you'll get 26 over 57. Okay. All right, boys. Thank you so much. That's all for today. I'll see you tomorrow. Enjoy the rest of the day.